Nebraska on Tap, the source for everything educational and informational about groundwater in agriculture. If you are an ag producer or a citizen of Nebraska, this show is made for you by the Middle Republican Natural Resource District.
Now it's time for our weekly show, hosted by Heather Disming.
Hi everyone, welcome to this week's edition of Nebraska on Tap. We are so excited to have our interviewee this week be Kurt Grimm. He is the CEO and sales manager of Nutradrip. They are out of Kansas and they do a lot of subsurface irrigation installation. But that isn't the only thing that they get into. So listen into this interview that I have this week with him and learn a little bit about subsurface irrigation and other options that Nutradrip offers to its customers.
My name is Kurt Grimm. I'm with Nutradrip Irrigation Systems. We're located in Hiawatha, Kansas. We service the Midwest. Corn and soybean farmers are excited to be on the podcast today.
Well, so you run Nutradrip, which you guys do a lot of different things when it comes to running that subsurface drip plus the nutrients that goes into it. So some of the topics I'd just like to talk about with you today, a little bit on water savings.
You bet. So anytime you can put water underneath the ground versus on top, we're going to get rid of that evaporation component. The other big water savings comes from evenly distributing the water across the field. So when you take a standard flood irrigation practice, for example, the distribution uniformity on that is really poor. Mm-hmm. With subsurface drip irrigation, we have emitters in the drip line that are putting out the exact same amount of water, whether we're at the beginning of the field or the end of the field. Usually takes about 10 to 15 minutes for that water to travel from one end to the other. And from that point on, we've got uniform distribution across the field. So water savings is obviously a huge component of what we do, and growers experience a real reduction, especially when it compares to flood irrigation. I would say most growers are saving anywhere from 50% or more of their water compared to flood irrigation.
And when the water is in the ground, you don't have as much evapotranspiration as you would if it came out of a pivot. You know, being the water in the air or on the gated. What do the plants tend to look like under the ground next to those subsurface drip tapes?
Yeah, the roots go find that water. It's interesting when you dig down in the middle of a growing season. If it's been dry and the plants have been going to that drip line, it looks like a little city of roots concentrated around those emitters. It's really telling when you dig down and you find that the plant sends more of its roots wherever the water is. It's a great way then that sets us up for fertigation, because now we have this access to the root zone. Mm-hmm. The roots are already there, and now we can start spoon feeding nutrients into it.
And the drip tape runs how many inches deep into the ground?
10 inches to 16 inches deep. Somewhere between those 2 points is usually where we're targeting. We set that based on soil type, tillage practices. We need to look at the horizons of soil. We want to put the drip line in the A horizon. We don't want to be in the B horizon soil. And cropping practice makes a difference on that as well, but typically somewhere between 10 and 16 inches. A couple other considerations there is we want to be 6 inches below the deepest tillage pass, but no deeper than 16. If we go deeper than 16, we're starting to get too deep, and we're not going to be near as effective with water or nutrients if we're deeper than 16.
Yeah, understood. And then how do you deal with those elevation changes that happen in fields?
Sure. So there are two different kinds of emitters. So when the drip line is manufactured, they actually extrude an emitter into the drip line. The manufacturer we work with primarily is Netafim. They're the oldest founder of drip irrigation based in Israel. Their technology has what's called a pressure compensated emitter. And so inside every emitter, there's a pressure regulator. And once that pressure gets to 6 pounds of pressure, then it puts out a uniform amount of water. So we can go from the top of a hill to the bottom of a hill, and the pressure at the top might be 10 pounds of pressure. We might have 30 pounds at the bottom. We're going to put out the same amount of water on all those emitters. So we can go into rolling topography. We do a lot of work in terraces and waterways, and it's not just for flat fields.
And what again did you say was the average amount of time that it took from water to get from one end to the other?
Once we've ran the system once for the season, usually it takes about 10 to 15 minutes for that water to travel from one end to the other.
That's a pretty good pace.
Usually the engineering is based on 1 foot per second. Is kind of what the design is around.
Yeah, and you guys design these patterns and the ways that these will fit into the field as well, right?
Absolutely. Yep. So the first step of any drip system is a good engineered design. The design is super important because in order for a drip system to last 25 or 30 years, which is what we should be able to get out of these. Matter of fact, we have a system near York, Nebraska that's 38 years old and it's still running. But in order to get that longevity, we have to have the ability to flush the drip line. And what flushing means is the velocity in the drip line has to get to 1 foot per second in order to properly scour it or clean it. And so the design is really, there's two components to design, or there's multiple, but the two most important ones, one is about uniform irrigation, and the other one is about proper flushing. And so there's a flushing component that's designed into every system so that we can properly clean them. And kind of along those lines, one of the other questions we get a lot is, can I use surface water? Can I use canal water? Or and so, yes, there's a filtration component. We're going to filter that water, make sure we take out any particles or sediment or organic material that would get inside that emitter and plug it up. That's really what we have to protect, is we have to protect that emitter to make sure it doesn't plug.
Yeah, and I was watching too on one of the videos on your website where you guys do the lagoon water and how you clean it out and make it where it can also be put through the subsurface drip as well.
Right. So the last 3 or 4 years, we've been approached by a number of livestock producers that are trying to do better with their manure placement. And so when you think about being able to apply manure during the growing season, underneath the ground, there's no smell. Your neighbors aren't going to see it. They're not going to smell it. And then that's better for the plant, right? When we can put that manure right at the root zone during the growing season, the environmental benefit, the greenhouse gases we're saving, there's a whole bunch of great benefits to that. So we've been on a quest for the last 3 or 4 years to find some equipment that could cost effectively separate the liquids from the solids and put those into 2 separate lagoons, basically, or in some cases we're doing it right in the line, and we're separating the liquid from the solids. We're removing all of those particles so that the only thing we're sending to the field is that liquid, and we're doing it at a price point that is typically cheaper than what most people are applying manure for today.
Wow, that's very interesting. When it comes to pests and rodents, how do you guys mitigate those little guys from causing havoc?
Yeah, so definitely something that has to be considered. Ground squirrels and pocket gophers are the #1 rodents that cause problems. So the first step is if someone's considering putting in drip irrigation, is the field needs to be scouted. If those rodents are present before the drip line's installed, they will make a mess. And so we always go out, we scout the fields. If they're present, they have to be poisoned, trapped, anhydrous. There's lots of different ways we use to treat them and get rid of them, but there's kind of a pest management practice that needs to be implemented to make sure that we don't have problems down the road. The other part of that is when the drip line is installed, there's a part of the installation process is to properly pack around the drip line. If the drip line doesn't get closed up properly, the mice will actually crawl down in there and chew on it. So there's a number of things we do during the installation process to make sure that gets closed back up, the drip line is protected. If all of those things are done, we say that a normal number of leaks for a farmer is 1 leak per 5 acres. So we don't ever go out and say you're not going to have any leaks. There will be a few leaks. That's just part of having drip irrigation. It's just like maintaining tires on a center pivot or gearboxes. There's going to be some maintenance involved. But if we can make that maintenance manageable, and we actually have crews that go out and do that. We actually go out, we fix leaks, get the system started up in the spring. We have crews out today in the field doing that on a number of different fields in front of this rain. So.
Yeah, no, we are experiencing the snow currently.
Oh, shucks.
We're in that weird area here. And then what else would you like to add, or anything else you want to add that you think people should know about subsurface drip that we didn't touch on?
Yeah, so I think the other big component is, and this kind of goes back into a little bit of our history. So when I was in high school growing up, we had greenhouses with hydroponic tomatoes. And in a hydroponic environment in a greenhouse, 100% of the nutrients go through the water. Mm-hmm. And so when we installed our first drip system, it was kind of an aha moment for me. Like, now I have that level of control for my field, and I can spoon feed nutrients right to the roots of those plants. We have center pivots on our farm here in northeast Kansas on our home farm, and we also have drip. And we fertigate with those pivots, but we're limited on what nutrients work through a pivot. With a drip system, there's a lot more options. We have a lot more control. And so part of our company's vision is we're not just an irrigation company. We also get into the agronomy side and help growers manage their nutrients through the drip line to make them more efficient, make them more profitable, make that drip system pay for itself that much faster.
Yeah, well, it makes sense because when you're putting your chemicals into the central pivot, it's top down, and with subsurface drip, it's right there at the root zone, like you were talking about. So,
100%.
Yeah, well, that's great. And what type of agronomy add-ons do you guys do with your company?
So we do some initial soil sampling. So when we first started getting into the agronomy 6 or 7 years ago, we focused primarily on tissue sampling. And one of the things we learned through that process is if we didn't evaluate what was happening in the soil, the tissue sample didn't make sense. It's just not enough information. So now we're tying in-season tissue samples with in-season soil sampling and picking a couple spots in every field, like a high-yielding area and a low-yielding area, and then we're evaluating what the tissue sample is saying, what is the soil sample saying, and then based on that information, we can decide what nutrients are the most limiting. We're also doing a lot of work with biologicals, with humates and fulvic acids, other products that we can run through the drip line to really stimulate the plant, some growth regulators. There's a lot of different things we can do, a lot of different buttons we can push. And so we help growers in that journey, learning how to get the most out of their water and out of their nutrients.
I guess with that being said, what type of chemigation, or what does a chemigation process look like with the subsurface drip? Can you put stuff down right in there, or how do you?
Yeah, so the chemigation pump is typically set up at the well or at the filter station. It's usually tied to a controller. So we'll go into that controller and we'll program and say we want to put on 50 gallons of fertilizer in zones 1, 2, and 3. We have a flow meter on our fertilizer pump, and it turns it on and puts out 50 gallons in those zones. So it's a very simple process. Most of these drip systems can be remotely operated from someone's phone or computer, and we make that as seamless as possible. The automation that's out there today makes that process very simple to do, and there are a few products we can't run through a drip system, so water quality is very important. That's another thing that we do. We have a staff person here that just is solely dedicated to water quality and making sure we don't plug up a drip system with high iron or manganese. Those two minerals can cause problems for us. So there's a lot that goes into that, but yeah, the fertigation is a big component of what we do.
Well, it sounds like you're on top of your game there if you already have somebody analyzing all that to make sure that you have your best practices set forth whenever you go out again.
Yeah, 100%. We've got 6 or 7 sales guys in the Midwest, and it takes a lot of support to keep all those systems going. I think this season we've signed up about 25,000 acres for maintenance. So we've got crews out doing maintenance on acres. There's just a lot you learn when you go out and you maintain a system that's 20 or 30 years old, and you see what works and what doesn't. But I think the big message is drip irrigation is a technology that can work if it's managed properly, but it does take support. It's not something you can just put in the ground and forget about. There are some things that need to be managed properly.
Yeah, and also, too, on your guys' website, you have a very cool video of you installing subsurface drip irrigation at Nutradrip.com, and I think that's great. So if anybody wants to go check out that video, they should.
You bet. And we also have host a number of agronomy meetings. We just finished those up here this week, and in the fall season, we usually have some field days around the country. So people sign up on our email list, or we also have a texting service. We'd be glad to share that information and get people out in the field and get to touch it and feel it and see how it's working.
Yeah, I think that's a great option for somebody who is curious about the subsurface drip, and especially your company where you guys dive a little deeper and get into the chemigation and the fertigation and everything like that with the product too, to make sure it's up to quality par.
You bet. One other thing we should mention specifically in Nebraska, or folks that are currently flood irrigating, is there is an NRCS EQIP program that helps cost share conversions from flood to drip. And there's also a program through the Rural Energy Efficiency that will cost share pivot to drip. So there are some cost share programs out there. If growers want to take a look at that, we can help them evaluate their options there.
That's awesome, because it is a very big, important step if somebody wants to switch things up.
For sure. It really helps. You know, a flood irrigation system is a low-cost system, and so sometimes it's hard for growers to get over the initial investment that's required for drip. Drip is a large investment up front, but it has a long-term payout.
Yeah, clearly it does, especially if you're working on systems that are 30 years old.
You bet. And I think, you know, especially today where the land market is so elevated and growers, you know, have to pay $10,000, $15,000, $20,000 an acre for going out and expanding their operation. I think our message is do better with what you have. Let's make the best of every acre you already own, and that's really what we're about.
Yeah, no, I love it. Well, thank you so much for coming on to our show today and talking to us about your company and all of your knowledge that you have with subsurface drip. We really appreciate it, Kurt.
You bet. Thanks for having me on.
So I hope everyone enjoyed my interview with Kurt. It was so great to be able to talk to him and get a little bit more information verbally about what goes on with subsurface drip irrigation, especially since he's been in the business for so long. And if anybody is interested in Nebraska, the University of Nebraska-Lincoln Extension also did the advantages and disadvantages of subsurface drip irrigation in a research article written by many. So just once again, subsurface drip irrigation is a low-pressure, high-efficiency irrigation system that uses buried drip tubes or drip tape to meet crop water needs. These technologies have been a part of irrigated agriculture since the 1960s, but with the technology advancing rapidly in the last 3 decades, it's definitely gotten better. So that completes our show for this week. Don't forget to like and subscribe so you always know when we launch a show for the week, so you can be one of the first listeners. You can also go to www.nebraskaontap.com to find our newest shows and to check out our RSS feed. We are on rss.com, YouTube, Spotify, and Apple Podcasts. We will catch everybody again next week. We'll talk to you later. Bye-bye.